Today we're going to look at more practice of multiplying radicals. So what we talked about is taking a single radical and multiplying it by a binomial. So in order to do that, what we want is to distribute. Whatever's on the outside, it needs to get multiplied by everything that's on the inside. But now remember, when you're doing your multiplication, you have to make sure that you are multiplying the correct type of numbers together. The 10 is under the square root. That can only be multiplied by another number that is also under a square root. So notice that in this first term, there's a number 5 that is outside of the square root. That's going to have to stay as it is. But then we are going to be able to take 10 times 2 under the same radical. I'm going to bring down that addition sign and we're repeating the process. But notice that 10's under the square root and then we have a 6 under the square root. There is no number that is outside of the square root, so we will just have one big square root where it's 10 times 6. Now, notice that I didn't actually multiply those numbers together because I now want to go through and simplify to see if we have at least two of the same number. So notice that 10, I can break that up into 5 times 2. 2, I'm not going to be able to, but remember, these are then what we call prime numbers. So if it helps, I'm going to write just those prime numbers. So I got to ignore the 10 because I broke it up. So we really have 5 times 2 times 2 under that radical. And now I can clearly see that, hey, they have a pair. That pair needs to move outside. So this original 5 now is going to be multiplied by the pair, but I only write that number once because I only have one pair. That single 5 that didn't have anything to pair up with has to stay under the square root. So notice that 5 times 2 on the outside is 10, and we have a 5 under the square root. I still now have to do that to the second radical. So I didn't multiply the 10 and the 6 together. I can break up 10 into 5 times 2. Neither one of those can get broken up any further. 6, I can break that up into 3 times 2. So notice that I'll bring down that addition sign. I'm only going to put those prime numbers back underneath. So the 10 and the 6 we don't need because we broke that up. We have 5 times 2. I'm going to switch this around. I'm going to put the 2 together and then the 3. So notice that once again, we seem to have a pair of 2's. So I'm going to be able to move that one time because I only have one pair to the outside. And then notice that I have two numbers that are not paired up. Those are going to be multiplied back under the square root. So notice that 5 times 3 is 15. So we have 10 root 5 plus 2 root 15. Because the 5 and the 15, we know that we can't simplify that any further, and we don't have the same number under the square root. We're not going to be able to actually add these any further because they're not what we call like terms. So that means that I'm done. That's my answer. So let's go ahead and do the same idea with the next one. Notice that we've got a single term getting then multiplied not once, but twice. But because that 5 is under the square root, it only can get multiplied by numbers that are under the square root. Notice that if there was a number, technically there's a 1, but if there was some other number outside, then that number would get multiplied by any number that was outside as well. Okay, so we have the square root of 5 times 5 root 2. So once again, the outside numbers we multiply together. So 1 times 5 is 5. And then under the square root, I'm not going to multiply those together yet, but we'll have 5 times 2. I'm going to bring down that addition sign and repeat. The outside numbers, 1 and 3, get multiplied together. So that's 3. Then under the square root, we'll want to multiply 5 and 10 together. All right, so if I go back to that first square root, if there are numbers that I can break down to find pairs, I want to do that. But 5, remember, is what we call a prime number. That can't get broken down. Same thing with 2. So because I can't break those numbers down and I don't see 2 of the same number, I am going to have to just multiply those together. So my first term is 5 root 10. If I look at the second one, notice that I can't break down the 5. However, the 10, I can break that down into 5 and 2. So I get to now ignore the 10. We'll keep the 3 outside, but under the square root, we really have 3 prime numbers. We have 5 times 2. So we've got a pair of 5s, which means that nothing happened to the first term, but that 3 is now going to get multiplied by a 5 once because I only have one pair. And then the 2 that didn't have a pair will stay under the square root. So we have 5 root 10 plus, now when I multiply 3 and 5 to give me 15, because once again, I can't break up the 10 any further under the square root, and the 10 and the 2 don't have the same number, I'm not going to be able to add these any further, so this would stay my final answer. So that's a monomial, so one term being multiplied by a binomial, which is 2 terms. But we also practiced when we have a binomial times a binomial. So let's take a look at this next example. There are several different ways for you to go about doing this. Remember, we want to think of it as either doing the box method or the distributive property. So for me personally, I like to do the distributive property. So I like to break up the first parenthesis and I like to keep the second one the same. So that means that I want to take that negative 3 root 5 and I want to multiply it by what I'm keeping, which is the square root of 5 minus 4. Then I go back to what I broke up, which was then negative 1, and that also has to get multiplied by what I'm keeping, which is the square root of 5 minus 4. Because now we're back to what we did in those last two problems. I can take what's on the outside and I can distribute it. So notice that the square root of 5 on the outside gets multiplied by the square root of 5 on the inside. Notice that it's the negative 3 that's going to get multiplied by this negative 4. So we're going to have the negative 3 staying the same for the first term, and then under the square root, we'll have 5 times 5. Notice that when I then distribute, negative 3 times negative 4 is going to give me positive 12. But I also have the square root of 5 that I was distributing from the outside. Notice that we have a pair of 5s, so right off the bat, I'm going to be able to move that to the outside with that negative 3. So we'll have negative 15 plus 12 root 5 from that first half of our problem. Now I need to take the negative 1 and I need to distribute that to both of these terms. Well, because there's no square root on the outside, that means that I'm going to have negative 1 times the square root of 5, and then I'll have negative 1 times negative 4, which is positive 4. So then I can bring those terms down. Notice that we have 4 terms, but we have some like terms. We have 2 numbers, and then we have 2 square roots that have the same number underneath. So let's finish combining those. Negative 15 plus 4 is negative 11. And then when I want to combine those like terms with the radicals, I'll deal with the numbers on the outside. So 12 minus 1 is going to be a positive 11. And then remember, we keep that number under the square root the same. Because we don't have a square root with that negative 11, I can't combine these any further. That is my final answer. Notice that in this last problem here, I see a binomial, but it's quantity squared. So that means that if you have something being squared, that exponent means that you are multiplying it by itself twice. So I'm back to like what number 3 was. I'm going to go ahead and I'm going to break up this first parenthesis and I'm going to keep the second one the same. You know what? Actually, I think I'll do the box method here so you can see it that way. So remember, box method, it's a 2 by 2, which means there's 4 boxes. So if we're creating our boxes, remember, I always want an addition sign, breaking up my boxes. So we're going to have the square root of 5 plus 5 on the top, and then we'll have a square root of 5 plus 5 on the side. All right, so now I want to multiply those outside terms to fill the boxes up. So square root of 5 times square root of 5 is underneath in the first box. Then notice that the 5 and the square root of 5, one is outside the square root and one is inside, so I'm not going to be able to actually multiply those numbers together. Same thing with the box down here. There's an outside number and a number under the square root. And then 5 times 5 is 25. All right, notice that in this first box, we have the same number underneath that square root. So that means that that's just going to turn into the number 5. Notice that what we have here on the diagonal are like terms. So I get to add the numbers that are in front. So 5 plus 5 is 10, and I get to keep the square root of 5. The last box was the number 25. Notice we have one more thing we can combine. 5 and 25 add up to 30. Because one number has a square root and one doesn't, we're not going to be able to combine those any further. So 30 plus 10 root 5 is my answer.